If A is parallel to B and B is parallel to C, then A is parallel to C. So I wrote that. This is the book definition. If A is parallel to B and B is parallel to C, then A and C are parallel. And then small caveat, all lines must be in the same plane. All lines must be in the same plane. I mean, yeah, this is the actual definition. You don't want this in the hallway so no one bumps into you while you're walking? Yes. Right, no one pulls your earbuds out. So, most of you guys would say if this line and this line are parallel, and this line and this line are parallel, does that make these two lines parallel? Not necessarily, because they're in different planes. So it has to be all the lines in the same plane. They all have to fit on a sheet of paper. So in a regular class, I give this definition. If multiple lines are parallel, then they're all parallel to each other. You don't have to write that one down. That's too easy for you. That just kind of clears it up a little bit. Is there any way to confuse this one? Or what's the purpose of doing this? Well, what would be the purpose of having multiple sets of parallel lines? Because more lines is more fun? Yes. Not necessarily, right? So an application question would look like this. Hey, what's that? A transversal. So if I have this angle and this angle are congruent, and this line, and this line are all parallel to each other, what can you justify about that angle? It is also congruent to the given angles because corresponding angles are congruent between these two lines. So if these lines are parallel and these lines are parallel, corresponding angles are congruent for the third set. So it kind of is the transitive property for corresponding angles, all in the same part. So there's parallel, and then the notation for parallel we're pretty familiar with. Then what do you think this one says? What's that? The transitive property of perpendicular lines? No. Is it not on there? Cool. I think I left the property off of the actual title off of it because it was dumb and I didn't like it. There isn't a name for it. It just says Theorem 3.9. That's weird. So what do you think this one says? Or can you describe what you're seeing?
It's two parallel lines that intersect.
No. What?
Two parallel lines that intersect at the same point.
Does it say A and B are parallel anywhere on here? No. Does parallel mean 90 degrees? No. It says that A is perpendicular to D. And it says that B is perpendicular to D. So if you know that A and B are both perpendicular to D, what can you justify about A and B? That they're parallel. And you can justify that because you have a pair of congruent corresponding angles. And when corresponding angles are congruent, it forces the lines to be parallel. So again, only true if all lines are in the same plane.
This is the name of it?
No, there isn't. It's just called Theorem 3.9. Yeah, which sucks. I hate that. And the blue part's the important part. All lines must be in the same plane, but if A is perpendicular to D and B is perpendicular to D, then A is parallel to B. Is that a duh theorem, or is that something completely new you've never heard of before? Is it kind of a duh theorem? if two lines are perpendicular to the same line, then they're parallel to each other. So in the regular class, I offer the Baker speak. I said if multiple lines are perpendicular to the same line, then those lines are parallel to each other. You don't have to write that one down. That's just for me to kind of clear it up a little bit. So we can justify that these lines are parallel because their corresponding angles are congruent. Or you can just kind of scrap the transversals speak and say if A and B are both perpendicular to D, then A and B are parallel to each other. And we have one last one. Theorem 310, the perpendicular transversals theorem. So what do you think this one says?
If the transversal is perpendicular to all the lines, if the transversal is perpendicular, then all the angles are 90 degrees.
So there's one part missing here. The part that's missing in the diagram should say, so right now we know that A, B, and C are all parallel to each other, but we only know that D is parallel or perpendicular to A. So if these three lines are parallel and D is perpendicular to A, what can you justify about D and B? They are also perpendicular. So speaking wise, again, all lines must be in the same plane. If A and B are parallel, if A is parallel to B and C, and A and B are perpendicular, then B is perpendicular to D, and C is perpendicular to D. Holy alphabet. Blah. So realistically, if you have a set of parallel lines, and one line is perpendicular to one of those parallel lines, it's perpendicular to all the rest of them. I think that's what the red box is hiding. If multiple lines are parallel and one line is perpendicular, then that's also perpendicular to all the parallel lines. It's like geometry diarrhea, right? Parallel, perpendicular, perpendicular, parallel. It's a lot of stuff, isn't it? So there's not much to do with this. This is really just, can you wrap your brain around the concept? So I'm going to diverge off of your notes for just a little bit, but we're going to come back to those here in a second. All right. Today, the main goal, and this is the only words that I'm asking you guys to say, like yesterday was congruent or supplementary. Today it's going to be parallel or perpendicular. That's what I really want you guys to grasp, the difference between what is parallel and what is perpendicular. Do you feel like you have a decent idea of doing that? Yes? Okay, cool. So we're going to talk about this. We're not going to write it down. All right? We're going to talk about this. It says, prove the perpendicular transversal theorem. Right now, you know that A, B, and C, D are parallel. You know that this line, and this line are parallel. You also know that EF is perpendicular to the purple lines. So you know that the purple lines are parallel and the red line is perpendicular. We are trying to prove that EF is perpendicular to CD. So you know purple's parallel, and you know that the top purple line and the red line are perpendicular. We're trying to prove that these two lines right here are perpendicular. How would you go about justifying that?
Form the
90-degree angle, angle 1, 2, and 3.
But how, okay, so that's where we're going. We're trying to prove that either angle 1, angle 2, or angle 3 are 90 degrees. Now, could you figure out some geometric ways to say that those are 90 degrees?
If E is perpendicular to AB and CD is parallel to AB, then CD is perpendicular to ED, and then the angle E, the 90-degree angle on perpendicular.
So that is the theorem, though. That's what the theorem says. The theorem says if the purple lines are parallel and the red line is perpendicular to one of the purple lines, then if so facto, the red line is perpendicular to the other purple line. That's what the theorem says. But go back to yesterday. Go ahead.
Since we know that lines AB and line CD are parallel, and we already have a right angle given to us.
Where?
then we can-
Okay. This one right here.
Yeah.
I know this is 90 degrees.
Can we label that just so?
Yeah, that is. No, yeah.
So we know that line's angle we know that line's 90 degrees, and since we know that the lines are parallel, that means that the corresponding angle has to be.
That's what we're looking for. Corresponding angles, by definition, says that how big is angle 2? 90 degrees. Now, angle 2 is definition 90 degrees corresponding angles. Now, if you have a right angle there, what do you know about the red line and the purple line? They're perpendicular. So you have to use one geometric concept, the concept of corresponding angles, because these lines are parallel, corresponding angles are congruent. So if this is 90, that's 90. And because this angle is 90 degrees, by definition, the red line and the purple line are perpendicular. That's how it works. You don't have to prove it every time. You can just say the perpendicular transversals theorem. That's getting you guys to see why it works every time. A student says, according to Theorem 3-9, that line AB and line BC must be parallel because they are both perpendicular to line BF. Explain why that kid is dumb.
They're on different planes.
Because they're on different planes. So when you look at AB, is AB perpendicular to BC?
Yes.
Yes. Is BF perpendicular to BC?
Yes.
So why are those two lines not parallel? Because they're on different planes. That's why they have to be on the same plane. So they are perpendicular standing alone, but they're not parallel when you lump them all together. Alright, man, this one blows my mind every year. The following statement describes a set of railroad tracks. Based only on this statement, make a conclusion about the rails and the railroad ties. Pause. Do you guys know what rails and ties are?
No.
This and like
You don't?
this.
The rails are the things that the wheels go on, right?
Okay.
And then
The rails are what the train rides on, right? You ride on the rails. The ties are what tie the rails together,
The wooden things.
depending on where it's manufactured. Okay? So, based only on this information, the railroad ties are perpendicular. The railroad ties are each perpendicular to one rail. So that says, I know this. What conclusion can you make about the rails and the railroad ties?
They're all perpendicular.
That is the most ambiguous answer I've ever heard in my entire life. They are all perpendicular.
the railroad ties
The railroad ties
are parallel.
are parallel. Does that make sense?
Yeah.
Rails are parallel. Can you say anything else?
Railroad ties are
The railroad rails.
What
parallel.
if I was in there laying rails like that?
Right, so that they were all
the railroad ties are each perpendicular to one rail. So you're right, you have to read it carefully. They're each perpendicular to one rail.
And if they're each perpendicular to one rail, and the line and the rail is parallel, that means they're all parallel to one rail.
So in this statement right here, you can say the rails are parallel, and you can say the ties are parallel. What about the rails are parallel? One railroad tie is perpendicular to one rail. One railroad tie is perpendicular to one rail. So that is all you know. You know that one railroad tie is perpendicular to one rail.
One railroad tie is perpendicular to both rails.
So you can conclude that this railroad tie is also perpendicular to the other rail. This is fun, right? No? Who knew parallel perpendicular could be so complicated? Alright, this is my last one. So somewhere on a blank space on something, see if you can draw that and make it happen. At the end of the day, I only care about the relationship between Apple Road and Evergreen Road. So this is just practice. I don't think you can do this in your mind. Read the statement, draw it, and then justify it. Read, draw, justify. Anywhere on some white space. And then when we're done, I'm going to select some lucky contestant to come draw it on the board. Who thinks they got it? Parallel or perpendicular?
Apple Road and Evergreen?
That's the question.
Parallel.
Parallel?
Yeah.
Anybody get perpendicular? So does your picture look like this?
Yeah.
Wait a minute.
Is yours allowed to look completely different?
Yes.
Yes. So this whole problem keys on how you drew Apple first. You could did anybody draw Apple like this? Did anybody draw Apple like this? No, you guys went with straight up vertical and horizontal lines. So you could do apple is perpendicular to berry. Berry is parallel to cornflower. Cornflower is perpendicular to daffodil. Daffodil is parallel to evergreen. So you could have drawn it any numerous numbers of ways. But at the end of the day, what do you know about E and A? They're parallel to each other.
Mine was wonky because I didn't have mine go all the way through.
Yeah, so I mean, I think last year people were trying to draw streets like this, like apple, and then they were like intersecting it with every like they were drawing actual roads and then going to do an erasing. And then it got like super complicated to figure out what was going on with what. So this is I want you guys if y'all are in that row, Mason's row, you're doing number 16. Caroline's row is doing number 17. This row is doing number 18, and this row is doing number 19. So 16, 17, 18, 19. And this is going to be our homework for the night. This is today's homework. So there's 4 questions, there's 4 answers. It's a 100, a 25, a 50, a 75, or a 0.
Wait.
16, 17, 18, 19. And we'll select one speaker from the row to give me the answer. So raise your hand at the 17 row. You're 17. That is the only question you have to do. You guys are in the 18 row. You guys are in the 19 row. 4 questions, 25 points apiece. See what happens. Huh?
Isn't it just one question?
Well, I'm assigning 4 questions to the class. So you better make sure you lean over next to your neighbor and be like, hey bro, parallel perpendicular before I select a random student to answer. So at the end of the day, your justification is parallel or perpendicular. How do A and D relate? Feel free to draw pictures. You did do that? Would anybody like to volunteer as tribute for their row? Oh, what? You ready? 17.
I got A is perpendicular to
A and D are perpendicular.
If you draw it on it, it helps it.
A, B, B, C. Perfect. Perpendicular. Volunteering as tribute? You have to raise your hand and sing the song. Okay, then you can. Just kidding. Go ahead. I'm good.
I'm looking for the correlation between A and D, right?
Yes.
A is perpendicular to D.
A is perpendicular to D. A, B, B, C, C, D. Yes. Perpendicular. Hashtag math. Any tributes from row 1 and 4? Who? Danny's been volunteered as tribute?
He's been voluntold.
You gonna try it, Danny?
For number 19, A and D are
Perpendicular. So we got A, B, B and C, C and D, they are perpendicular. Nailed it. There's 5 people over there. Someone's gotta take one for the team. You can almost see it up there.
Kennedy, why don't you do it?
Okay, Kennedy, you can. You've been thrown under the bus.
A is parallel to D.
A and D are parallel. It's even drawn. It's already drawn for you. A and B are parallel. B and C are parallel. C and D are parallel. It's all parallel, so the answer's parallel. Yay!
It's like the easiest one that nobody wanted.
Everybody gets 100 on their homework today. So at the tail end of class, this is lingering out there, right? You have some questions that you may or not be finished with. If you would just like additional practice, you could read through some of these questions. This is not homework. I'm not assigning this. This is just for you to see if you understand what's going on.